Hello everyone, first of all thanks for being here in my YouTube channel. Let us conduct experiment number 3, measurement of resistance and inductance of a choke coil by using 3 voltmeter method. See here 3 voltmeter they mentioned. You must use 3 voltmeter in your circuit diagram. You should not use 3 voltmeter plus 1 ammeter in your circuit diagram. If you use so, definitely that is going to be a wrong experiment because they mentioned 3 voltmeter method, right? We'll see what is the use of choke coil and its application. For example, we all are using tube light for lighting purpose, right? This one is a tube light and this one is choke and then this one is starter. Choke coil is particularly for to limit the starting current. I mean to limit the fast moving electrons at the time of starting. See here, choke is present here and it limit the starting current. If it is choke is not there, definitely fast moving electrons goes like this and here to here, here to here. What happens within a short interval of time, this tube will break, right? And also choke is for to induce high voltage at the time of starting. See here to here there is no connection, right? Electrically it is not connected, only gases ionization. So high voltage is required at the time of starting for energizing I mean that ions, I mean argon will be there inside, mercury vapor will be there. So that purpose high voltage short interval of time we need, right? So after once the lamp will be glowing, after that starter is not required, right? So electrons will move here to here, here to here once it energized, right? I'll be giving a logic for understanding the choke coil. I'll compare with a cricket match. Bowler, he used to bowl normally. Suddenly, he will be reducing the speed. What it means? He'll be giving choke, right, to the batsman. So here also same thing. Choke coil is for to limiting the current or to limiting the fast moving electrons, right? Next, we'll move on to the experiment. Aim of the experiment is this one. Apparatus. First, you learn circuit diagram. Based on the circuit diagram components, you make a apparatus table. And circuit diagram, see here phase neutral supply because single phase 230 volts 50 hertz. MCB is present for on off condition as well as safety purpose, and fuse will be there, safety. If suppose part occurs, short circuit occurs, automatically it will get burnout. Don't get confused. Here two safety devices we are using because of safety. If it is one is not working, definitely another one will work, right? Next there is a auto transformer, variable AC. This auto transformer is optional. You can connect here to here, will get only one reading, right? Auto transformer for more number of readings. Okay. Next voltmeter, because 3 voltmeter they mentioned, 1 voltmeter across supply, 1 voltmeter across this resistance. Okay. This resistance value is known value. Okay. And 1 voltmeter across a choke coil, right? 3 voltmeter we connected in the circuit diagram. We need to determine this resistance and then this inductance of choke coil. Next, based on the circuit diagram, we will make a tabular column. This one is supply voltage. This one is voltage across resistance. This one is voltage across choke coil. One thing you must remember here, KVL is not applicable. Usually KVL is equal to what? Supply voltage is equal to drop across VR plus V choke, right? But choke coil is present. That's why this supply voltage is not equal to drop voltages. It's not equal. For example, 230 you are giving. Voltage across resistance will get 100. Here will get 160. Total how much? 260, right? Because choke is present oppose the supply voltage. I mean according to Lenz's law, right? Already I told you, choke is for to inducing high voltage at the time of starting, right? So that's why I'll be giving 230 over here. Here 100. Here 160. Based on these values, we are going to calculate resistance and inductance of choke coil. So here there is a calculation part. This one is a power triangle for choke coil. This one is V choke. So this one is a voltage across resistance. This resistance, okay, and this one is voltage across supply, right? So choke coil current always lags by voltage at an angle of phi, right? So if you want to calculate this cos phi, so according to cosine rule, Vs square is equal to this Vs square is equal to Vr square plus V choke square plus 2 Vr V choke cos phi, right? So cos phi is equal to what? You'll get like this formula from this one, okay? And after that, this one is very important. This resistance and then this voltmeter is for to calculate current. Keep it in your mind because resistance values they are given 250 or 500. They used to give these values, right? So we are going to calculate current over here, and after that we can calculate Z choke, right? V choke by I because current is same here to here. After that, cos phi is equal to what? R by Z, adjacent by hypotenuse, right? R by Z. R is equal to Z choke into cos phi. Sin phi is equal to what? Opposite by hypotenuse over by h. So XL by Z choke. So XL you can calculate. So XL is equal to what? 2 pi FL. So L is equal to XL by 2 pi F. We can use this formula also for calculation of Z choke. Z choke is equal to root of R square plus XL square. So from this you can calculate, because R is known value. Here R is a known value, and XL is equal to, you'll get root of Z choke square minus R square. You'll get XL value. So XL is equal to 2 pi FL, L is equal to XL by 2 pi F. Like this you have to calculate. Next procedure part, before conducting the experiment, everything must be off position, right? Make the connection as per circuit diagram. Auto transformer must be minimum position. You just check it and switch on the power supply. Use the auto transformer step by step. Note down the all the meter readings and switch off the power supply. Remove the connection. Result: resistance of the choke coil and the inductance of the choke coil found to be, will get some value. Okay. Welcome to Basic Electrical Laboratory. Let us conduct experiment number 3, measurement of resistance and inductance of choke coil by using 3 voltmeter method. This choke resistance and inductance we are going to measure, and then 3 voltmeter we are using V1, V2, V3. Right? So as you can see the diagram, see circuit diagram is present over here. There is a phase and neutral, single phase supply, and MCB is present for safety as well as on-off condition purpose, and then fuse is connected series with the circuit. Fuse must be connected always in series with the phase, not neutral, because this one is an AC experiment. Next there is auto transformer. Auto transformer is for different readings. I mean, if you give 100 or 150 or 200, for more number of readings we have auto transformer. If you want, you can connect, otherwise no need this auto transformer. Directly you can connect over here and you will get only one reading. And voltmeter across supply V1, voltmeter across resistance, this resistance. Okay, so this resistance is particularly for to measure current, because only 3 voltmeter they mentioned. They not mentioned 3 voltmeter plus 1 ammeter, but here ammeter is present. You should not use ammeter in your circuit diagram, right? That's why they have given this part, resistance part, and 1 voltmeter across this resistance, and another 1 voltmeter across this choke coil, right? Let's start the connection. I'll be using this auto transformer output. I'll not be using this 230 volts. Directly you'll get only one reading from this one, and you'll get here different readings. That's why I'm using auto transformer output. So phase 2, as you can see the diagram, see auto transformer phase 2, rheostat positive terminal or phase terminal, right? See here resistance is connected, and resistance another terminal 2. See here to here 250, here to here 500. I'll be using 250 now. This is 250 and then this is 500. Okay, so I'll be using 250. See, resistance another end 2, choke coil one end. So this one is a choke coil one end. So choke coil another end 2. See here, choke coil another end 2, neutral, right? See here, neutral it is connected. So choke coil another end 2, neutral. Now I'll connect voltmeter across supply, voltmeter across choke coil, voltmeter across rheostat, right? So this one will take V1 or V source, and then neutral to neutral. So this voltmeter across supply, and another voltmeter V2 or VR. So across this rheostat. Right, so neutral to or negative to negative. Next, 1 voltmeter across choke coil, right? Here, other terminal to neutral to neutral or negative to negative, right? So we connected everything. Before taking the reading, auto transformer must be 0 position. See here, all the voltmeters reads 0 value, because we are not given voltage, right? So what I will do, I will vary auto transformer into 100 volts. Okay. So I have given supply voltage 101.3. Just I'll note down the supply voltage reading 101.3. And what about VR voltage across this rheostat, that is 94.63. And what about V choke is 24.81, right? See here, in this experiment KVL is not applied because a choke coil is present. Addition of these two will not get this value. According to KVL, input voltage is equal to sum of drops, right? So this is a drop across this rheostat, drop across this one choke coil, right? So note down the readings. I'll take another one reading. Just I have given 20 volts supply. See here, you have to note down the readings. Supply voltage is 220. Voltmeter across supply, and then voltmeter across choke reads 207.4, and voltage across choke coil is 54.93. And next you can take for 230. Okay. See here, for 230, this one is supply voltage 230, and V2 reads, voltage across rheostat reads 216.5, and voltage across choke coil is 56.94. So based on the reading, you have to calculate power factor and then resistance of the choke coil and then inductance of the choke coil. See, you have to use these formulas. Okay. See here, for this experiment, frequency is equal to 50 Hertz. Supply frequency is 50 Hertz. Keep it in your mind. Then you do the calculation, you get everything. Right? So, thank you. Sorry,